Hi there. My name is Mr. Danny, and I'll be your host for today's installment of The Excitement of Science. On today's episode of our show, The Excitement of Science, we will be discussing the conductivity of solids and the viscosity of liquids, both very exciting parts of the sphere of knowledge that is science. So, why don't you just sit back, relax, and enjoy today's episode of The Excitement of Science. I'd like to start off today's episode with the viscosity of liquids, but before we can really get into this property, I'd like to go ahead and define it. So, guess that's what I'll do. Our friends over there at the Merriam-Webster Dictionary have defined viscosity as the property of resistance to flow well in a fluid or semi-fluid. But you know what, that's just kind of a vague general definition. I don't know if I would award students full points on a test for putting that down. So I'm going to go ahead and give you a deeper definition. Merriam-Webster defines it as the ratio of the tangential frictional force per unit area to the velocity gradient perpendicular to the direction of flow of the liquid. Now isn't that just quite interesting?
Man, I don't want to learn about this stuff.
Well, now come now, Timmy. It's not that hard. Let me go ahead and show you through demonstrations. Viscosity is basically how easily something can flow. The higher the viscosity, the less something flows. For example, glass, an amorphous solid, has an extremely high viscosity, so high that you cannot actually see it flowing. But after 20 years or so, an upright pane of glass will be thicker at the bottom than at the top because the glass flows downward. Now, how many of y'all knew that? Water is much less viscous. It flows very freely. Just take Niagara Falls, for example. At least 202,000 cubic feet of water flow over the falls every second. Still don't get it? Let's go to our good friend T-Storm to help you understand.
Hi, I'm T-Storm, and I'm in the kitchen. What am I in the kitchen for? It's a great place to discuss viscosity. Now I've acquired 2 frying pans, water, and oil. Watch now as I pour each into the pan. As you can clearly see, the oil took much longer to pour into the pan than the water, making oil a much more viscous liquid than water. I've got one more demonstration of viscosity for you. See that glass bottle right there? Now watch as I shoot it. Oh, it's all viscous and wet.
I have to say I learned quite a bit in that first part of the excitement of science. I didn't know all that stuff about viscosity. But now for part 2. We're going to discuss the conductivity of solids. Now, just as I did in the first half, I'd like to go back to our friends over the Merriam-Webster Dictionary, see what they think about it. Over there in Merriam-Webster Dictionary, they define conductivity as the quality or power of conducting or transmitting as a reciprocal of electrical resistivity. It's quite interesting if you ask me, but we're not going to leave it at that. We never do on the excitement of science. We make sure we educate you to the fullest of full extents. So let's go back to our friend T-Storm, and he's going to teach you about conductivity. Let's go.
Hello, I'm here in my living room to show you how the most exciting property of conductivity can be used in everyday, modern, bustling society. This lamp is connected to an insulated copper wire that when plugged in to an electric outlet emits light When plugged in to an electric outlet, electricity races through the conductive copper wire into the lamp, and the electricity is turned into light.
Well, T-Storm, I really must say that's quite interesting. You learn something new pretty much every day. So, it sounds like the property of conductivity really must serve humanity and technology quite a bit, eh?
Well, funny you should say it, but no, conductivity can be quite dangerous. Let's say you're swimming in a pool, and a T-storm or even a normal thunderstorm comes by and zaps the water. The water is filled with conductive chlorine ions. If the ions are charged, it can electrocute you or anyone swimming in the water.
Really sad to say, but that's about it for today's individual episode of Excitement of Science. So why don't you go ahead and come back next week when we'll be discussing the theory of gravity. It's going to be quite exciting because gravity, you know, quite attractive. So I guess we'll see you next week. Goodbye for now.
Wait, I still don't get none of this.
Everyday, modern, bustling society. That lamp is powered through an insulated copper wire that when plugged in to an electric source well, funny you should say it, but no, conductivity can be quite dangerous. Let's say you're swimming in a pool in a thunderstorm or a T-storm come along and zap the water.
No way. Wow. Friends over there at Merriam-Webster Dictionary have defined it as the property of resistance to flow well in a fluid or semi-fluid. Or we could go, you know, just a tad deeper and say the ratio of the tangential force. It's so hard to say. It's such a deep. Okay. 4, 3, 2, 1.
Wait, I still don't get none of this.
Okay, stop. Okay, stop.